So we're now going to go on to the next bit, which has more of a focus on using SUVAT equations. Okay, so in this one thing we talked about last video is we said that well, we had U and we had A, and you'll remember that we used them in SUVATs sort of the same as before. Just one quick note here, because in the SUVAT v squared equals u squared plus 2as, because you're squaring, this one we can't use, okay? Because you know, if we have something like this and we talk about squaring it, you might just think, oh yeah, well, it's just 2 squared and 1 squared, but it's actually a bit more difficult than that, okay? But with something like, you know, we had this with S before, so ut plus half at squared, v equals u plus at, all of this sort of stuff, you can kind of handle the same way as we did before. So we're going to do some questions and take a look at this. So we've got a particle with this velocity, constant acceleration. So when we're reading all of this stuff, we need to be really careful to make sure we're in the right situation. So the situation here is constant acceleration. So that means that SUVAT is probably going to be the way to go. So it has this velocity. Okay, so it sounds to me then like this is, we can think of this as the start point of a journey. So the earlier velocity, if you like, you call u, don't you? We've got our A figure here, and we're using t equals 3 to find v. So SUVAT, what have we got going on in the question then? So we've got the A, we've got the U, we want to find the V, we've got the T. So that's this one from before, isn't it? Okay, so let's write that down. So V equals U plus AT, and V is what we're trying to find. So U, that's going to be, I'm going to write it in column vector form. So minus 3, 1 plus, and I'll put the 3 in the front. And then the A figure was 2, 3. Okay, so what's that? It's minus 3 plus a 6, and then it's a 1 plus a 9. Okay, so that's going to be, I'm going to write it back in I and J form now. So that'd be 3i plus 10j. Okay, so nothing really radically different. You just handle them as SUVATs instead. Yeah. Let's just go back and check the question. So find the speed. It does say speed, right? So this, at the moment, this is actually a velocity. So speed, that's when we need to find the magnitude of it. Okay, so we're going to do one of those ones there. And I've got written down in my notes, I've got 10.4 meters per second for that one. Okay. Anything else we need to do? The speed and the bearing at which it's traveling. So traveling about the velocity again. Traveling means moving, so it just wants the angle that goes with this. So 3i means 1, 2, 3 to the right. 10j means a lot up. Okay, so what we're going to do then, that's my right angle triangle. Write my 3, write my 10 there. It said bearing, didn't it? So bearing, it actually wants this angle here. So, well, you could, one easy way to do this actually is just change how you draw the triangle here. Maybe just do it like that instead, and then I can find my theta straight away. But if it says bearing, just make sure it is actually a bearing, okay? So tan theta in this case equals 3 over 10. So theta ends up being 16.7, and then it's a bearing. So that's the way we actually want to leave our answer for that one. Okay, so SUVATs, column vectors I use because they're a little bit more convenient, and we've talked before about things like when it says speed, make sure it's the magnitude, and bearing, make sure it is in fact a bearing. So let's do some more questions. So what have we got on this one? Let's make this a little bit bigger and then we can zoom in. So a particle moves with constant acceleration. So great, they've told me, again, that's that key phrase, haven't they? They've told me that it's constant acceleration. At time t0, 4, so that's 4, 0, I'm going to read that as, and that's 2 minus 3. t equals 2, it's the same question, isn't it? So it's v equals u plus at, which is going to be equal to, the u was a 4, 0. The t was 2 this time, and the acceleration was 2 minus 3. So what's that? That's 8 on the top, and that's a minus 6 underneath. And in this one, I think that's all I need to do, because it says find the velocity. That's also why it's perhaps just 2 marks. How about the next one? So at time t equals 0, the position vector of p relative... Okay, I need to read this again. So, right. So it's the same particle. They're saying that at the start it was at 1, 1. Yeah? So it was up here somewhere. And we know the velocity is that it cut 8 minus 6. So 8 minus 6, imagine the particles kind of going something like that, yeah? 8 minus 6, to the right and down, 8 minus 6. So it wants to know where it is after 3 seconds. Okay, so one thing with this is it didn't start at the origin, right? So we'll just need to take this into account when we answer the question, because S, or R if you prefer, for your SUVATs here, it tells you the displacement, it tells you the difference over the journey. It doesn't actually tell you where the thing is. So we just need to take into account that it's going to be 1, 1 plus that journey there. That's one way that you can kind of handle it. So what 3 seconds later, I've got the initial speed. Okay, so which one do I want to use here? Well, one of them that's got s in, so do I want to do ut plus half at squared? I think I do. So ut plus half at squared. So in that case, that's going to be equal to 40 times 3 in this case, plus a half of the acceleration. So that's 2, 3. So that will be 1 minus 1.5, something like that. That's the half a. And then the t squared is times 3 squared. Okay. So if you do this, this should tell you how much it's moved by. So it's 12 on that one there, plus 9. So that's 21, isn't it? So that's how much more to the right it will be. So 4 times 3 is the 12, and then the 9. The other bit is a 0, so I can ignore that. And then what is that? That's a 9 times a 1.5, so that's going to be minus 13.5. So this is how it moves, but you've got to bear in mind that it was at 1, 1 initially. That's the position vector. So it is that, yeah, but you also need to add on the 1, 1 initially. So plus the 1, 1. So it's actually 22 minus 12.5. Okay, so I'm sort of like adding vectors together is the way to do that. Sometimes there's other ways to do it, but I often find this is the easiest way to do it. The key here, though, is you need to remember that you're talking about the displacement when you have S and R.